Hello everyone. So today we are covering section 6.1, looking at your notes. So these are my lecture notes, but I uploaded the daily packets on Blackboard. So as you can see, there's some notes that you'll have to read through, and I will reference them throughout some examples. So if you guys have any questions, feel free to ask me about the concepts, but right now I'm going to start on section 1. Example 1. Example 1 states it wants us to simplify the square root of 36 over 16. So how do I simplify the square root of 36 over 16? So if we look at the steps, step 1, it says if the numbers aren't perfect squares, simplify the fraction under the radical. So I'm going to look at the numerator and the denominator. The numerator is 36. 36 is a perfect square because 6 squared is 36. And then 16 is also a perfect square because 4 squared is 16. So step 1, in this case, done. Step 2 says use the general equation given above. So I should have been a little more specific. What I'm using is we're going to use property 4, which is the quotient property, and the quotient property states that the square root of a over b is equal to the square root of a over the square root of b, as long as a and b are positive real numbers. So for step 2, let's do that. So the square root of 36 over 16, this is, so I should use an equal sign. This is equal to the square root of 36 over the square root of 16. Right, that was step 2. Now step 3. Step 3 says solve and simplify if possible. So the square root of 36 is 6 because 6 squared is 36. And then the square root of 16 is 4 because 4 squared is 16. So now we have to see if we can simplify. 6 is an even number, 4 is an even number. Since they're both even, I know for a fact that they are both at least divisible by 2. And in this case, that's the GCF. So if I divide this, so this actually should be equal. If I divide these, top and bottom, by 2, what do I get? I will get 3 over 2. And this is our answer. Now, let's do example 2. Example 2 wants us to simplify the square root of 48 over 75. So again, with our steps, for step 1, we want to, if the numbers aren't perfect squares, we want to simplify the fraction under the radical. 48 isn't a perfect square, and 75 is also not a perfect square. So I'm going to simplify it. So 48, the first perfect square is 16, and 16 times what is 48? That's 3. And for 75, it's going to be 25 times 3. Right? So before I continue, how did I do that? So one thing that you'll need that I highly recommend for squares, cubes, fourth roots, fifth roots is always have a table. So starting at 2, because 1 of any, like 1 squared, 1 to the 100th, 1 whatever, is always going to be 1. So it's not going to help us. So let's start at 2. So I'm going to look at 2 squared, that's 4. 3 squared is 9. 4 squared is 16. Oops. Went ahead of myself. Let me go back. 5 squared is 25. 6 squared is 36. ... I would suggest to go down all the way until at least 10 squared. Okay, and then if necessary, then do 11 squared, 12 squared. All right, but in this example, I don't need to go any higher. So how did I do this? I look at 48, and I'm going to go up, and I'm going to see the first number that is less than 48. So 7 squared was 49, so the first number would actually be 36. 36 does not go into 48 evenly, so then I'm going to look at 25. 25 also doesn't go into 48 nicely. But then I look at 16, and I'm thinking, okay, 16 times 3, that is 48. And because it does, so 48 divided by 16, if you see it, you'll get 3. And so that's why I reduced this, so it's going to be 16 times 3, because this is the very first perfect square from 48. So now looking at 75, I'm going to do that again. So you would actually start maybe at, you'll still start at 7 squared because 8 squared is 64, so 7 squared is 49. But 75 divided by 49 does not give you an integer. Then you go to 36, but 75 divided by 36 is also not an integer. But then we get to 25. 75 divided by 25 is 3, which is an integer. So what does that mean? 25 is the very first perfect square we get. So 25 times 3, that is 75. So this is how we simplify. And as we can see, in the numerator and the denominator, we both have a 3. So what does that mean? Oops, dang it. That means I can take these 3's and they're reduced to 1. And since they're reduced to 1, this becomes 16 over 25. Now 16 is a perfect square, 25 is a perfect square. So what can I do now? I'm going to go to step 2, and I'm going to use that rule, the quotient property rule. So the square root of 16 over 25 is also the same as square root of 16 over the square root of 25. And then we're going to solve. Okay, so technically we're going to simplify. So square root of 16 is 4, because 4 squared is 16. And the square root of 25 is 5, because 5 squared is 25. Right? So, and then 4 and 5, we can't simplify this anymore. So this is our answer. Okay. And then before I go on into the next section, some of you, so I know I put the step 1, step 2. So how do I expect you to solve this? So let's go. I'll do example 2 again. So for example 2, if it says simplify 48 over 75, I want it to be this, and then so just say 16 times 3 over 25 times 3. Okay, and then if you want, you can just immediately tell me this is square root of 16 over square root of 25, which is 4 over 5. Right? If it makes you more comfortable, we can add one more, which would have just simplified this, and you would have gotten the square root of 16 over 25. It is up to you, but this is the minimum amount of work I expect from you guys.